All right, I'd like to move on to the next section of the Rust book, which is control flow. I already have my editor here. I'm kind of excited for this one because this means we can actually start doing things that do things, options. Erase that now because I don't think we're going to need it. So what do they say? Control flow. Deciding whether or not to run some code depending on if a condition is true, and deciding to run some code repeatedly while a condition is true are basic building blocks in most programming languages. The most common constructs that let you control the flow of execution in Rust code are if expressions and loops. All right, let's go. Let's figure out how they do if expressions. If expressions. An if expression allows you to branch your code depending on conditions. You provide a condition and then state, if this condition is met, run this block of code. If this condition is not met, do not run this block of code. Create a new project called branches. I called my project control flow. Let number equal 3. All right. So this example, let number equal 3. Now we're writing our first if statement. If number is less than 5, do this. Print. Condition was true. And else. Print. Condition was false. Okay, and let's run that for safe measure. Condition was true. We know that 3 is less than 5. Okay. Here I just believe they're explaining if else. If condition is true, do this, else do this. Pretty straightforward. Moving on to the next example. Let's try changing the number. Well, if it is greater than 5, what happens? Condition was false. It is worth noting that the condition in this code must be a bool. If the condition isn't a bool, we'll get an error. For example, try running the following code. Oh, when they say bool, they mean Boolean, as it has to be true or false. So this condition, this is the condition right here, has to evaluate to either be true or false. It can't be something else. For example, if you were just to say number, like they have there, they took out the else condition, but having number there and by itself is not true or false. And what does the error say? Expected type bool for a condition, but found type integer. That's a no-no. Let's go back to what it was. All right. So what they're saying here is that unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types into a Boolean type. You must be explicit and always provide if with a Boolean as its condition. If you want to use an if code block to run only when a number is not equal to 0, for example, then you have to try to change the expression following it. So over here what they did is if number is not equal to 0. Now this block is changed completely, so we can get rid of that. And we can add this statement here. Number was something other than 0. Number was something other than 0. Right now it's currently 7. Other than 0. But if we put 0 in here, nothing happens because there is no else block. If we add an else real quick, print number was 0. Number was 0. Now when we run it, number was 0. Cool. Alright, so handling multiple conditions with else if. You can have multiple conditions by combining if and else in an else if expression. For example, this one looks kind of long, so let's write it out. Let number equal 6. Got that. And then we start our if else loop. Well, it's not necessarily loop, just statements coming down. If number is modulo mod 4, if number mod 4 is equal to 0, then we print, what do we print? Number is divisible by 4. Does this make sense? Number is divisible by 4. And to be clear, when they say modulo, modulo just means that when you divide a number by 4, the remainder is equal to, in this case, 0. If we say number mod 4 equal to 1, that means when we divide a number by 4, the remainder is 1. In that case, you can think of 5 as an example of where that suffices or is true. So next we do an else, and they even provide it for us. Else if. Else if. Break that down. Oh, I didn't add the statement yet. The thing that evaluates to a Boolean. Number divisible by, or number mod 3 equal to 0. So I didn't get the hang of what they're trying to do here. Mod 3 equal to 0. Print line. Number is divisible by 3. And they're going to give me another else if number mod 2 with the same pattern. Number is divisible by 2. And last, we're just gonna have our else, which is gonna be the catch-all for anything that is not caught in the previous conditions. So if anything is not divisible by 4, not divisible by 3, not divisible by 2, will fall into the else block, which they're very explicit about. Add the print line. Number is not divisible by 4, 3, or 2. So currently number is 6. And when we run this, we see, just like they got, number is divisible by 3, because 6 is divisible by 3. What about if number is 7? 7 is a prime number. Shouldn't be divisible by any of these. Number is not divisible by 4, 3, or 2. For safe measure, let's go with, what is a number that's divisible by 2 but not by 4? 10. Let's go with 10. Ten is divisible by 2. And for safe measure, let's check to see if the 4 case works. Pass an 8 in there. 8 is divisible by 4. Moving down. So using if in a let statement, because if is an expression, we can use it on the right side of a let statement. Okay? If is an expression. That means if return something. That's interesting. So let's see how we use it. We can do let condition equal true. And I need to put the semicolon after that. And we can say let number if condition. I see. So if condition is true, we can say that the number equals to 5. Else, we can say the number equals to 6. And now if you recall, because these designate a scope and this does not have a semicolon after it, this is an expression, and expression is returned. So if the statement is true, we're returning 5. If the statement is false, or at least the condition here, if the condition is true, we're returning 5. If the condition is false, we're returning 6. And then they have a line here saying print. The value of number is the value of number is 5 because the condition is true. Let's change it to false, and just to confirm theory, the value of number is 6. All right. Remember that blocks of code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. This means the values that have the potential to be results from each arm of the if must be the same type. And an example of them being opposite types is down here, where they turn this, when they change this one to a string. Now if we change this to a string, as you can see, this if statement can evaluate to either a number or a string, and that should error out. See, they expected an integral variable, but they found a string instead. Yeah. And if I put 5 here and switched it, they will be expecting a string and put find an integer. Expected a string, found an integer. So it expects whatever the first possible return value is, that type. That's good to know. Going into loops, going into loops. Repetition with loops. It's often useful to execute a block of code more than once. For this task, Rust provides several loops. A loop runs through the code inside the loop body to the end and then starts immediately back at the beginning. To experiment with loops, let's make a new project called loops. I'm not going to do that. I'm just going to do it in this project. It's control flow. Meh. Oh, Rust has 3 kinds of loops: loop, while, and for. Let's try each one. Repeating code with loop. The loop keyword tells Rust to execute a block of code over and over again, forever, or until you explicitly tell it to stop. Here's the example. This might break something because this is just a infinite loop of print again. I'm kind of scared to run this line actually. Ready for this? Again. Let's exit out of that. Oh, you can Control C to forcibly stop a program. All right. Fortunately, Rust provides another more reliable way to break out of your programs than using Control C. You can place a break keyword within the loop to tell the program when to stop executing the loop. Recall that we did this in the guessing game, in the quitting after a correct guess section of chapter 2. And here's an example. Yeah, here's an example. Let me write this out real quick. So here we're going to define a mutable counter. Counter has to be mutable because it's going to be changing. Question, why is it underlined? That pink underlining looks sort of weird. Okay, let result equal loop counter plus equal 1. Okay. We still have to end the loop. So we started a loop here, right? And at the beginning of the loop, we add to the counter, and then we do a check. If counter is equal to 10, we break. And then we have a line right after break. That's interesting. Counter times 2. And at the very end of this, we have an assertion that the result is 20. Okay. So the way I read this is we define a counter right here, which is awkwardly underlined in pink. Have no idea why. We make it 0. Then we have a result, which is going to be defined by the end output of this loop. This loop is going to be an expression. This loop returns something. We start the loop off by incrementing by 1. So we go through 1, 2, 3, 4, all the way to 10. And then once we see 10, we hit a breakpoint. But the last thing to be seen by the code block is counter times 2. So count is 10 here. We break, and then this is going to be returned. Is it? That's awkward because there's a semicolon after that. That isn't. Let's run this to confirm. It finished. It didn't give me an error. Let's print this out. The value of result is the value of result is 20. Okay. This is interesting. It's seemingly breaking one of the rules, but maybe there's not. Maybe there's something I just don't know. Anyway, let's move on. Conditional loops with while. It's often useful for a program to evaluate a condition within a loop while the condition is true. The loop runs. When the condition ceases to be true, the program calls break, stopping the loop. This loop type could be implemented using a combination of loop, if, else, and break. You can try it now in a program if you like. And they have an example here where it's seemingly a countdown. So let's run that. We have let mutable number equal 3. All right, while number is not equal to 0, do something. Print just the number. Okay, I can date that, and then we do number equals number minus 1, and then we do print liftoff. So this essentially is a countdown. Run it to make sure it works. 3, 2, 1, liftoff, and we have it. One thing I am kind of curious about is we did a +1 earlier. I wonder if we can do a -1, and if that compiles. 3, 2, 1, yeah. So this is equal to number equals to number minus 1. It's just shorthand for it. Okay. Looping through a collection with 4. Let's erase this now. You could use the while construction to loop over the elements of a collection, such as an array, for example. And they list out this example. So we're creating an array. If I remember correctly, arrays have a fixed size. 10, 20, 30, 40, 50, right? And we can see the annotation is this. We have our type and we have our size. Let mute index equals 0. And we can access the array by index. And they're saying that we can do a while index is less than 5, because we know what the index max is. We can do print the value is of A at whatever index we were at that moment in time. So this is one way, and then within the while loop we have to do an index plus equal 1. They wrote it out explicitly, but plus equal 1 should do the same thing. And then we should not see an error. Let mutable index unexpected token. Actually, I'm not sure what this means. Oh, I didn't have a semicolon here. And we have the value of 10, 20, 30, 40, 50. So that's one way of looping over it. Another way that they want us to use is a for loop. And here's the for loop example. So here's the while loop. We're going to erase the while loop. We're also going to erase the index. So they're saying that with a for loop, we don't have to use the index explicitly, which using index explicitly can lead to errors, because then you have to know exactly how many elements are in the array. Given that the array is fixed, you should know, but if you pass in the wrong number, that is your own mistake. And it's a runtime error. How if we do for, we can do for element in a dot iter for element, and they put the type there for us so we get to see it. And we can print the value is element. And this would do the same thing. It does the same thing, less lines of code, and it does look a little prettier. Alright, so they summarize everything I said up there, so we're going to skip that. And then we're going to go to this other way of writing the countdown. So here's what the countdown would look like using a for loop and another method we have not talked about yet called rev, to reverse the range. So the countdown that we wrote earlier was 3, 2, 1, liftoff, right? So what they're saying here is we could just do all of that in a for loop for the most part. For number in, and then we explicitly define a range 1 to 4 dot rev, and then within the code block we do the print line again, which is just the number. And outside of it, just like before, we print lift off. Alright, so to mess around with this code a little bit, to figure out what exactly this is doing, I believe this is a range from starting from 1 to 2 and not including 4, so 1, 2, 3. If we wanted to go to 10, we'd have to say all the way to 11, right? And that will give us 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off. And this is calling a reverse, making it go in reverse, starting from 10 instead of 1. And then we have the print line. And now we've made it to the summary. And in the summary, they give us homework. You've made it. That was a sizable chapter. You learned about variables, scalars, and compound data. Oh, ooh. The summary is not for this section. The summary is for this entire chapter. We have reached the end of this chapter. Huh, that's interesting. And now they've given us homework because we reached the end of this chapter. They want us to try building, convert temperature between Fahrenheit and Celsius, generate the Fibonacci number, print lyrics to the Christmas Carol, 12 Days of Christmas, taking advantage of the repetition in the song. When you're ready to move on, we'll talk about the concepts in Rust that doesn't commonly exist in other programming languages. Ownership. Alright, well, we've reached the end of the chapter. And just to be clear, that is chapter 3. Yeah. Common programming concepts from variables, mutability, data types, how functions works, comments, and control flow. We know enough to be dangerous. We know enough for them to ask us to write small programs. Congrats. Hope that was helpful. Peace.